Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today in this session, I want to discuss about model paper 2 questions from module 1. So that is surface interaction and friction. In previous session already we have discussed about model paper 1 questions. So in this session, I will explain model paper 2 questions with answers. So topic is model paper questions and answers. The main topic is surface interaction and friction. So in this, he has asked in examination model paper, explain the importance of Boden-Tabor theory in friction. So what is the importance of this theory in friction? So already various theories we have studied in friction topic, friction module. But particularly, so in this paper, model paper, he has asked about Boden-Tabor theory. So the Boden-Tabor theory, also known as the Boden-Tabor theory, is a fundamental concept in the study of friction, particularly in the context of understanding the microscopic origins of frictional forces. So the concept of Boden theory is to study of the friction and understanding the microscopic origins of the frictional forces. The theory developed by F.B. Boden and D. Tabor in the mid-20th century. So it provides insights into the nature of frictional interactions between surfaces. So what this theory states, we will see. Microscopic contact points, that is real contact area. The Boden-Tabor theory posits that the actual area of contact between two surfaces in frictional contact is much smaller than the apparent or macroscopic contact area. So whenever two surfaces are in contact, so it states that the actual area of contact in between these two surfaces is much smaller than the apparent or macroscopic contact area. This real contact area consists of a multitude of microscopic contact points or aspirates. So this area is called a real contact area. Aspiratory interactions means the frictional force is primarily due to the interactions of these aspirates, which deform elastically or plastically under load. Next, adhesion and fouling. So the adhesion means at the macroscopic level, adhesion between the aspirates of the two surfaces contributes significantly to friction. So the theory suggests that these micro welds or adhesive bonds need to be shared for relative motion to occur. So the adhesion between the aspirates of two surfaces, it contributes significantly to the friction. So what this theory suggests, that these welds, the micro weld, are bonding between two surfaces. You can call it as adhesive bonds, must be shear. So then only the relative motion is possible. Next, fouling. Fouling, when aspirates are hard and penetrate into the softer surface, The asperities are hard, but it will penetrate into the softer material. Flowing effect occurs also contributes to the overall frictional force. Next, material properties. So material properties are very, very important. Elastic and plastic deformation. So the Boden-Tabor theory emphasizes the role of material properties such as hardness and yield strength in determining whether the asperities undergo elastic or plastic deformation. Theory affecting the frictional characteristics. Thereby this affecting the frictional characteristics. So the surface roughness. The roughness of the surfaces in contact influences the number and the nature of asperity contacts, thereby impacting the friction. So this theory depends upon these material properties. These material properties again, the elastic and plastic deformation. And another point is friction coefficient. The frictional coefficient depends on load. According to the theory, the coefficient of friction is largely independent of the apparent contact area and is more dependent on the real contact area. Already we have seen in previous slides about this real contact area, which increases with the normal load due to the deformation of asperities. Next, nature of surfaces. The materials and the surface treatments. The surface treatments like lubricants and oxidation or surface structuring. So texturing can alter the adhesion and deformation characteristics, so thus influence the coefficient of friction. So what are the applications? Engineering and design and tribology applications. The insights from the Boden-Tabor theory are crucial for designing materials and surfaces in mechanical systems. So why? Because where friction plays a critical role, such as in bearings, gears and brake systems, and everywhere in mechanical systems, friction plays very important role. So these theory are very crucial for designing materials in mechanical systems. The tribology, the theory forms a foundational element in the field of tribology, the study of friction, wear and lubrication, aiding in the development of better lubricants and wear resist materials. So what is the importance? The fundamental understanding. So what is the importance of the theory in friction, the Boden-Tabor theory? It provides a fundamental microscopic understanding of friction, moving behind empirical laws to explain why friction behaves the way it does at the contact level. So it explains the empirical laws related to this friction. So predictive power. By understanding the mechanism of friction at the asperity level, the theory allows for better prediction and control of frictional forces in various applications. So leading to improved performance and longevity of mechanical systems. So better prediction, whenever better prediction is available, you can control the frictional force in various applications. So automatically it leads to improve the performance, improve the performance of the product and improve the lifespan of the product, that is efficiency. You can improve by applying this Boden turbine theory for predictive of power. So innovative material design. Insights from the theory have driven innovations in material science, leading to the development of advanced materials with tiled frictional properties for specific applications. So next question is, describe briefly about modified adhesion theory and its importance in friction. So Boden-Tabor theory already we have studied in a previous question. In this, he has asked modified adhesion theory. So the modified adhesion theory is an extension of the classical adhesion theory of friction already we have studied. In adhesion theory of friction. So this is the modified version is extension of this theory of adhesion theory of friction, addressing some of its limitations by incorporating additional factors that influence frictional behavior. So the theory provides more comprehensive understanding of the microscopic interactions between surface and contact. So what is the basic concept? The classical adhesion theory suggests that friction arises due to the adhesive forces between the microscopic contact points. Those points are called as asperities of the two surfaces. So the friction arises due to the adhesive force between the two contact points. Those points are called as microscopic contact points. So the modified adhesion theory refines this by including additional factors like surface roughness, material properties, and the presence of contaminants or lubricants. So whenever presented the lubricants, so material like roughness and the surface roughness and material surface roughness will be smoothened. That can influence adhesion and friction. The lubricant also influence the adhesion and friction property. So what are the key modifications in this? Surface roughness. The theory takes into account the real surface roughness and how it affects the true contact area, which is often a fraction of the apparent contact area. Elastic and plastic deformation. It considers the elastic and plastic deformation of asperities affecting the real contact area and the adhesive forces. Next, temperature and environmental effects. The modified theory includes the impact of temperature, humidity, and other environmental factors on the adhesion between surfaces. Next, third body effects. It acknowledges the presence of third bodies like lubricants, oxides, and wear debris. Can alter the frictional forces by either reducing direct contact between surfaces or changing the nature of the contact. So what is the importance in friction? This theory importance in friction is more accurate predictions. By incorporating a broader range of factors, the modified adhesion theory provides more accurate predictions of frictional behavior across the different materials and conditions. This is crucial for designing systems with precise frictional characteristics. Next one is enhanced material design. Understanding the modified adhesion mechanisms helps in designing materials and coating with a tailored frictional properties, leading to improved performance in applications like the mechanical applications, bearings, seals, and sliding contact surfaces. So these are enhanced material design. The theory applicable in this type of designs to understanding the modified adhesion mechanisms. It's tribological applications. This theory is valuable in the field of tribology, aiding in the development of better lubricants and surface treatments that can effectively reduce friction and wear in the mechanical systems. Next, industrial relevance. So, industries such as automotive, aerospace, and manufacturing benefits from the insights provided by the modified adhesion theory, enabling the development of components that operate more efficiently and with great longevity. The fundamental research. The theory contributes to fundamental research in surface science. So suppose we want to research in this surface science and contact mechanics. So this theory, adhesion theory, contributes to develop our research areas in surface science and contact mechanics. So to enhancing the understanding of how microscopic interactions translate to macroscopic frictional force. So microscopic interactions to macroscopic frictional forces. So this theory helps in a fundamental research. So the modified adhesion theory refines the classical adhesion theory by considering additional factors. What are the additional factors? So these additional factors are surface roughness, material properties, environmental conditions, and then third body effects. So its importance lies in providing more accurate predictions of friction, guiding the design of materials and systems with specific frictional properties, and also supporting advancements in tribology and industrial applications. So these are the references I taken for this question paper 2, model paper 2 questions. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.